Alright, we'll understand a few concepts about lists and dictionaries in a little more detailed format so as to enable us to write a good Python code whenever we have to deal with a lot of data. Okay, I just want to first of all get you into something called as list comprehension, or we also have something called as for comprehension. Okay, so now let me say I'm going to have a list of numbers. Okay, so let me say I'm going to have a list of numbers, and this numbers is going to be 4, 5, 6, 7, 8, 9. Okay, and I'm going to define a function. Okay, so I'm going to define a function which can say something like this. It returns the squares. Okay, it returns the squares, okay, of any particular list. Let me just call it as list for now. Okay, of any particular list. Okay, I'll call it as LST, and let me define a new list. Okay, that is going to be an SQ. Let me define it as an empty list, and I'm going to call this particular function in which I'm going to pass this list, that is numbers. Now when I pass the numbers, it is going to call this particular function, that is squares, and for every element in list, for every element in LST, what must I do? I should do I square, that means the element square, and I need to append this particular value in this SQ list. So I will do SQ dot append, that is I square. I'll do that. Okay, this is not called as list comprehension. I'm so sorry. I'm just going to that concept. This is just, we are doing an append, and we are going to return. Finally, we're just going to return the square, that is the new list. We are going to return the new list, which means I need to take that into, let's say SQ list, and I'm going to say print the numbers, and I'm going to print the square of the list. Right? So if I run this out, it's going to be, okay, so SQ list, I'm going to say that 4, 5, 6, 7, 8, 9, I just passed that, and I got the squares back out here. This is how I got a square. But there's another easier way to do this. It says you don't need to have any of this. You do it with the method called as list comprehension, right? So I just need to return, what do I return? I need to return another list. I'm going to return a new list, which is going to be whatever is the element, right, which is going to be, I'm going to pass, okay, for every I in LST, I need to make a new list which is going to contain I square. For every I in list, I'm going to make a new list which is going to contain I square, and I'm going to pass that out. Function F5, enter, and you get the same answer. This is using list comprehension. I want to understand it better. I want to define a function which is going to return to me the even numbers. Let me say even. Okay, def even. It also takes a list and will return for me another list, which means it has to be a list. Return for me another list for every element again in list. Okay, what must I do? I must do I modulus 2 is equal to, I need to check if I modulus 2 is equal to 0 or 1. Okay, I want to return the even, so it should be equal to 0. What do I need to return? A list whose every element is I, for every I in list. If I mod 2 is equal to 0, then I return an even. So now if I print, instead of square of list, if I print even of list, okay, or even of numbers, if I print that out, F5, it's just going to return to me the even numbers from that big list. Is that clear? Okay, so if you want something like this, you can also have certain conditions where you say, Okay, I want even numbers. I want the even numbers, but also if along with the even numbers, I also want that the number should also be greater than 5. That means it should be an even number and that I should be greater than 5. So now if I print it out, it's going to just return 6 and 8. It's not going to return 4. Even though it's an even number, it comes away from the condition of greater than 5. Okay, so this concept is called as list comprehension. Okay, we go to a new concept now. Alright, let's understand the concept of argument packing and argument unpacking in using lists and tuples. Okay, we're going to understand that. Say for example, I'm going to define just a simple addition function. A simple addition function which takes a comma b, and it will return what? A plus b. Right, it will return a plus b, and I can call this anytime. So I'll just save it for now and say addition. Right, addition, save it out, run it. So it's already defined. I can just call it anytime and say, 4 comma 5. It's going to add it and return, and it's going to pass 9. But can I do something like this? 4 comma 5 comma 6, I want to add 3 numbers. No, you can't do that. Why? Because it says add takes 2 positional arguments, but 3 were given, which means you had to give only 2 positional arguments, but you gave 3. That is wrong. You can't do that, right? So is it possible that I can make a function with variable arguments, where I can say, yes, you give me as many arguments as you want, no problem, I'll handle it out. Yes, it does that. Okay, so you can redefine your function where you can say star numbers. And now, what is the type of numbers? You can have a look what it is. And for now let's do this much. Let's print the type of numbers. Okay, and we will understand the return part of it a little. We'll just comment this out and we'll understand it.